Hello everyone, my name is Ming. Um, I'm making this video for the convenience of um, following students who would like to work on the Opencv library and also try to use the Intel architecture, instruction set architecture the SSE or the AVX ISA to accelerate those multimedia applications. Generally speaking, the Opencv library is kind of complicated. It's not that easy to work on, so I would like to make this video as a guidance for the following students. So currently, I'm in the folder of the Opencv. The version is 2.4.5. As you can see, there's a lot of folders here, and I create a folder which is called release, and following the step of the online manual, which I just install the software here. One thing to mention is that after you do the SAMake, you will need to do the sudo make install, because the default path where you put your header files and also the shared library is in the user local, which normally you need to have the sudo right to put those files in that path. Other than this, I would like to show you something that's useful. So basically, as you can see here, there's a folder called samples, and if you go there, there would be different kind of examples written in different kind of languages. For example, if you go to C here, as you can see, there are a lot of multimedia applications, and for me, I'm working on a finding object in the C folder. I'm also working on actually I'm only working on this in this folder, and I would like to show you one file which is quite useful, is this buildall.sh. So basically it's a bash file, and you can use this file to directly compile whatever you want, like a contour, something like this. It says compiling contours, and then the executable of contours will be generated under this directory. And this folder, you can copy this one to an upper level, which is the .cpp folder. There are more examples here which are written in CPP, and as you can see, it doesn't have a build all folder by default in this directory, but as soon as you copy here, that's what I did, build all.sh, and if you get inside, you need to change something, like if you given one argument here, you will need to change it from .c to .cpp, because in this folder everything is .cpp. And then here, if you want to compile all the files in the batch, you will need to remove the C part, because you're only having CPP file here. So let's see other things. Other things like if you want to make for one of the examples here, you need to first go to release folder, and there is a makefile here. I'll show the makefile. So for example, let's see you want to compile the face recognition. Just search for face recognition. So there is one example face rec demo. So to do that, you just type example this rec demo, and then do it. That would do it. Build everything, and I just made some some changes, so it shows some kind of error, but that doesn't matter. I just want to show you how these things are work. Other than this, there's one folder which is quite important. Is this module folder. Note that there's a same folder which called modules inside the release folder, but if you want to rebuild your shared libraries, you will need to change the file inside this module folder. So let me give you a tour. So there are different kind of applications, as you can see, based on the name of the folders, such as the object detect and image processing and the core contribution, anything like that. So for example, let's go inside the core. So normally there is the same txt. I guess that is used to as a template, and then you can fill in the informations to generate some CMake file for a specific machines. And for other folders include performance, SRC, and test. Test is relatively easy, straightforward to understand. As source include, these are straightforward. But performance, I never use this. Maybe they do some optimization about the code to make it fast. But yeah, maybe. But I don't know. So let's go to the source, which is quite important. As for me, I changed one important file which is used for my final class project, which is the matrix.cpp. So basically I use the stdni. I use the Intel SSE instruction set and the AVX instruction set to accelerate the process. So what I modify here is to add the header file, which is immintrinsic.h. Then the main function that I change is called the min-max lock. As you can see here, for this one, I did some of changes. If you're familiar with the Intel ISA, like this M128 means I define a register which is of 128 bits wide, and that's load PS is to load 4 consecutive single precision floating point number into 128 bits register, which is called a main array. And then I do some modification to the original code to make it run faster. So forget about this part. There's one thing which is quite hard for beginners to get used to the files, is that all the files are put sort of randomly, and the only way to make sure that you can find the file that you want quickly is to look at the header file that you want to search for. For example, let's go back to the sample folder under the say example. So if I'm looking for the final object.cpp, okay. So if you look at this, there's several folders that it calls for. As you can see,